Okay, that's pretty bad penmanship, but I'm gonna fix that. So we're asked to find the inverse. We're asked to find the inverse at x equals 6, and we're asked to find the composite of the inverse in the original function at x equals 1. So let's start with the top one. To find the inverse, an inverse function just means the domain and the range have been switched. The domain is the x, and the range is the y. So the inverse of this function is going to be 6, 3, 8, 1, and then -2, 5. I just switched the roles of x and y. Okay, there's our first part. That's the inverse. The second part asks us to find the inverse at x equals 6. So we got to look at our inverse function that we made over here, find where 6 is for x, and then see what it spits out for y. 3 is what it gives us. Okay, because I just went to the inverse, I found where x equals 6 because this is where x goes in our function notation, and then I saw what it equals in x equals 6. It gives us 3. So that's the second part. This last part asks you to plug 1 into this new function. If you take an inverse and plug the original function into it, it's always supposed to give you the identity, x. Okay, so really this function right here is just x, and if you plug 1 into x, you get out 1. That's what this one should be. So just trying to recap that. No matter what the function is, if it has an inverse, and if you take a composite of those two things, it always makes the identity function, just the letter x. So if you're asked to find out the f composite, the inverse of f composite f at x equals 1, just had to plug 1 in there.